All right, so here we go. We're going to talk about your quadratics, things you learned before you got here, okay? So first of all, when I say the word quadratics, what should you be thinking of? What is a quadratic? When I say quadratics, what is a quadratic? Of what? What kind of shape? Okay, so yeah, a lot of people get confused by this word. A quad, I know it's quad is like the prefix for four, but it's not. In this case, quadratics, guys, when I say quadratics, I mean x squareds, your parabolas, okay? Your other forms of this. So I'm talking about your x squareds here today. Now there's many forms of this formula that you have seen. Okay, so there's three that we're basically going to talk about today. Okay, we have your different quadratic equations. The number one is your standard form. When I say standard form, it's this one. The ax squared plus bx plus c. Does that look familiar? The ax squared plus bx plus c. Okay, so this is your standard form. Okay, your vertex form, you might not recognize it because depending on the teacher you had, they may or may not have gone over it. You probably learned this in Algebra 2 if you remember it at all. It's this, the x minus h squared plus k. And the reason it's called the vertex form is because the vertex of this is always h comma k. So whatever this number and this number was, that was your vertex. Does anybody recognize that one? Yeah, a little bit. Okay. And then I have a factored form. Okay, so the factored form looks like this. X plus or minus, it doesn't matter, some number p, and x plus or minus some number q, okay? And they don't have to be p's and q's, they can be any numbers. Does that look familiar? Factored, it being factored, we kind of did it a little bit, right? When I said factor this. What do they all have in common? Yeah. This has a x squared. This has a squared. And now this one, does it have a squared? Because what are they doing? Multiplying. And if I were to multiply x times x, I would get x squared. So are they all quadratics? Yeah. Okay. So these are the different forms. Okay. We're going to concentrate mostly on, actually in PreCal, we concentrate mostly on the standard form and mostly on the factored form. Okay. Vertex form is sometimes useful, but not really. I mean, I can do other things with the standard and the factored that I can't do with vertex. All right. Let's talk about the anatomy. So quadratics, all of them are parabolas. Okay, they're all parabolas. So this is just in general, they don't all look like this, but this is just in general what a parabola looks like, right? So let's talk about the anatomy of a parabola, okay? What are these? Right here. What's happening? They're crossing the x-axis. So they are, of course, are my x-intercepts. Okay? They actually have 4 different names, but they all mean the same thing. So does anybody remember another name for them? They are called x-intercepts. They are also called zeros. They are also called roots. And they are also called solutions. Okay? Why they have 4 different names, I have no idea. But all 4 of those things mean the same thing. So if I'm ever saying, hey, find me the roots of this function, what am I asking you to do? Tell me where it crosses the x-axis. If I say find me the solutions to this function, I'm asking where is it crossing the x-axis. If I say find me the zeros of this function, I'm asking where is it crossing the x-axis. Does everybody understand that? Okay, they all mean the same thing. Okay? What's this down here? What's that? Say that again? Yeah, this is my vertex. This is my vertex, right? Basically, when it comes to parabolas, it's that center part, right? That's where it looks like the parabola is being formed. From here, it's going to go outward, or right? So that's your vertex. So you said it's or I said it's the center part. Usually, it goes right through the middle. Does anybody know what that's called? What does it look like it's doing? It's a what? The line of symmetry. Actually, you are correct, but we call it actually the axis of symmetry. It means the same thing. You said line, it's just called the axis of symmetry. So it's whatever line is going right through the middle of that parabola, right? Or through that thing. But think about it. It also goes through the what? Vertex. So once you know the vertex, you pretty much know the axis of symmetry. It's going to go right through it. Okay? And I know it's kind of close over here, but what's this one? What's happening there? It's the y-intercept. Okay? Parabola, all of these things are important, okay? You should be able to tell me, okay, what are the x-intercepts, or the zeros, the roots, the solutions, or whatever? Where's the vertex? Where's the axis of symmetry? Where's the y-intercept? Okay, so these are the important parts of a quadratic equation. Okay, are we good? All right. Let's talk about factoring, okay? Because this is huge, okay? When it comes to pre-cal and even calculus, you have to be able to factor. You have to be able to factor, okay? What do I mean by factoring, by the way? Break it down, right? Break it down, and when I say, okay, if I just say, what are the factors of 12? What are you thinking? Well, what did you do? You're looking for what? Two numbers that multiply to give me 12, right? Now, you can't think, if I can't say factor this equation, it's not going to be just two numbers, right? It's going to be two smaller equations that when multiplied will give me x squared plus 7x minus 8, right? You guys remember how to do this? So I need to end up here. Okay, I need to end up here in the butt cheeks, right? So how? How do I do this? Okay, so factors of what? What am I looking for? Good. So here's the trick. There's a trick here, right? So there's a trick. Does everybody, what form is this in? This is in standard form. This is in the form ax squared plus bx plus c. Does everybody agree with that? Okay, this is in the form ax squared plus bx plus c. So, the way I like to explain it is there's always four steps. There's always four steps. Here's my first step. Multiply a times c. Now, in this case, it seems kind of dumb to multiply a times c because why? A is 1. So is that really going to make a difference? No. Is A always 1? No. So that's why I'm telling you, right? That's why it's a step. So step 1, multiply A times C. Now, step 2, find factors of A times C that add up to B. Find factors of A times C that add up to B. Okay? So, yeah. Okay, so step 3, you're going to write those factors at the right end of the parentheses with an AX in the front. And then step 4, reduce each factor if possible. Okay? Reduce each factor if possible. So, here's what I want. Okay? So, here's my equation. My first step, multiply A times C. What was my A again? And my C is? -8. So, of course, 1 times -8 is just -8. Okay? So, there's my number. Step 2, give me factors of that add up to b. So give me factors that give me two numbers that multiply to give me negative 8, but they also add up to positive 7. Good. Does everybody agree that a positive 8 and a negative 1? Now notice how I went with it says write those factors at the end of the parentheses. Does everybody agree that's what I just did? And then it also says, and write an AX in the front. Okay? What was my A again though? 1. So I would write 1x, or do I have to really write the 1? It's really just an x. And then it says reduce each factor if possible. Do you understand what I mean by reduce? So here, because a is not always going to be 1, correct? What if it was a 2? So then it would say 2x plus 8. Just looking at this, if it said 2x plus 8, could I reduce that? Yeah, both of them by 2, and it would become x plus 4. Do you see how that works? Okay, so in this case, is it possible to reduce? No. So then guess what? I'm done. I'm done. That's my factors. Okay? Now, so that's just factoring. Here's where most students get confused. It says solving with factoring. Okay? Rule number 1, guys. Rule number 1. If I asked you to solve, I want to know what in the end? I want to know x equals what, right? X equals what? Okay? So, rule number 1. In order for you to even solve, it must be equal to 0. So your equation itself has to be equal to 0. So the way it is written, can I solve this? No. Now can I solve it? Yeah. You see the difference? So if it's not equal to something, just don't start randomly solving, because you can't. There's nothing to be equal to. Okay? So now, here's the thing. So here was my equation. I factored it, right? I factored it. So does everybody agree that here's what I have? I have x plus 8, parentheses, x minus 1 equals to 0. How does that help me solve? Good, because remember, you have to understand what's actually going on here. What are these two things doing? Multiplying, and they're equaling to what? 0. So how can you multiply and get 0 as an answer? Only one or both have to be 0. That's the only way, right? So then, do y'all remember what I called it? What can you do? Split and solve. So you can say, look, if this times this is equal to 0, then this first part must be 0, and this second part must be 0. Okay? So then now it becomes a very simple algebraic expression that all I want you to do is solve. What would you do here? So x is equal to? Negative 8. Over here? X equals to? Positive 1. So there you go. Most likely you're going to get 2 answers. Okay? Now, hopefully you're saying, that seems like a lot of work. That problem was way easier than I made it. Of course it was. That's the point. Because remember, when I give you a process, that process should work all the time, regardless of how difficult or easy the problem seems. Okay, does that make sense? Because here, I want you to do the exact same thing with this one. Okay? I want you to do the exact same thing with this one. So we'll do it together. We'll walk through it together. But you're telling me what to do. Same process, people. Same process. Okay? What's my first step? Which is? Well, yeah, a is greater than 1. It's 2. Right? So does everybody agree that a times c is 14, right? Okay, so step 2. Give me factors of that add up to 9. So how am I going to write this? Remember, so right now, just put the back part. A positive 7 and a positive 2. Does everybody agree with that? Now, that's the reason I told you to only use the back first, because you're going to jump the gun. Because what goes up front? AX. It's not always just an X, it's AX. And in this case, what was my A? 2. So I'm actually going to have a 2X and a 2X. Does everybody see that? Am I done? No, because what's my last step? Reduce if possible. Looking at just this, can I reduce this first one? No, they're both divisible by the same thing. Can I reduce this second one? Which is what? Does everybody see how that works? Does everybody see how that works? Any questions? Now, a lot of students ask me, well, isn't it the same thing even if I don't reduce? No. Why? Take a look at this. Because remember, when you factor, if you multiplied, shouldn't you end up with the same thing? Right? So look at this line right here. If I automatically, 2x times 2x is what? 4x squared. So I'm already wrong. If you do not reduce, it's going to be wrong. Okay? So make sure you reduce. And then here, in my reduced form, what's 2x times x? 2x squared. See the difference? Plus a 7x plus a 2x plus 7 gives me that. Got it? So now, how do I solve this? Remember, first of all, for it to even be solved, so now I can solve it, right? Okay? Now I can solve it. So, if I tell you, hey, this is all equal to 0, I can solve that. What do I do? Now, separate them. So I have 2x plus 7 equals 0, and x plus 1 equals 0. This one's easy. X equals -1. Is this other one that simple? Can you just tell me right away? Probably not. But so then what am I going to do? So 2x is equal to -7. So x equals to -7/2. Is that okay? Yeah, it's just a number, right? It's just a number as a fraction. That's really what, -3.5? Right? So that's fine. Remember, I prefer the fractions. Any questions? So you see why I give you the long process, correct? Because it works all the time. It works all the time. Any questions so far? Too easy? Do y'all remember this stuff? Good. Okay? Do me a favor, you try this one on your own. You try this one on your own. Alright, so one more time, guys. A times C, right? And then factors of that add up to B. And then write them in factored form. Don't forget your AX. Okay? Reduce if possible. And then separate and solve. Any questions on that? Any questions on that? We good? Good. Okay, something we've already done. Something we've already done. Okay, so this was part of your quadratics, or actually it was a whole different section, but it's very helpful here. Reducing radicals. Okay, remember what I told you? What do we not like when it comes to radicals? We don't like decimals, right? So if I ask you for the square root of 24, I don't want 4 point something, right? I don't want 4 point something. So do you remember what I do? Find the nearest what? What is that called again? Okay, remember, you're going to find, basically, what you're going to do is you're going to factor these numbers, factor them, but one of the numbers has to be a perfect square, right? Can you tell me, what are my perfect squares again? 1, of course, 4, 9, 16, 25, 36, 49. Uh-oh, hold on, can't write. 49, 64, 81. And does it stop there? No, it can be 121, 144, 169, and so on and so forth, right? So they go on forever. I don't really need those big ones because my numbers are not that big, right? So what I'm looking for is I'm looking for factors of 24, right? So two numbers that do multiply to give me 24, but one of them has to be a perfect square. So 2 times 12, is that 24? Yeah. But does that help me? Why not? Neither one of those is a perfect square, so give me another one. So 4 times 6. So 24. Does everybody agree that 24 is the same thing as 4 times 6? Which one of those is a perfect square? The 4. And I saw this mistake a lot on your homework, okay? So pay very close attention. So 4 is my perfect square, correct? What is the square root of 4? 2. So what comes on the outside? A 2, not the 4. Okay, a lot of people were just taking that perfect square and pulling it on the outside and telling me 4 square root of 6. That is not correct. Okay, you have to actually, but if the number comes on the outside, you actually have to take the square root of it. Okay, so what do I get? 2 square root 6. Okay, you get 2 square root 6. Is everybody good with that? Okay, the next one. I have 2 radicals, and what are they doing? They're multiplying. Can I actually do that? Yeah. How? Just multiply the numbers, right? As long as the radicals are the same, you can basically combine them. So then now I'm asking you, well, what's 5 times 18? 90. So I get square root of 90. Does everybody agree with that? Can I ask you a question? What if this was, instead of square root, this was the cubed root? Could I do what I just did? No. Why? The radicals are not the same. Okay? The radicals are not the same. What if this one was also a 3? Then could I do it? As long as they're the same, you can multiply them. Does everybody understand that? Okay, so I got square root of 90. Is that my final answer? No, because what can I do with that? Reduce it, right? Give me 2 numbers. When multiplied, give me 90, one of them being a square root. 9 times 10? Agreed? All right, and then which one's a perfect square? So what's the square root of 9? So what do I get? Easy breezy. We good with that? Any questions? So what happens though if I couldn't break the 90 down? What happens if I couldn't find 2 numbers? You just leave it, right? It's just the square root of 90. Nothing. Okay? If you cannot factor it, you leave it as that. Yeah. Any questions? All right. Okay, sticking with this theme of radicals here. Okay, we have something called rationalizing the denominator. Okay, rationalizing the denominator. So, what happens when you take a radical, a square root, or a root of a fraction? Well, there's a simple rule. The rule says this. The rule says if you're taking a radical of a fraction, you're basically taking the radical of the top over the radical of the bottom separately. Okay, and vice versa. Right? If I had a fraction where there's a radical on both top and bottom, essentially I can bring them into one fraction, or I can split them up. So it works both ways. Okay? But there's a problem with this. Okay? And the rule is this. We never want a radical in the denominator. You never want a radical in the denominator. Okay? So, what we're going to do is something called rationalizing the denominator. Why is it called rationalizing? Because radicals, guys, they're called irrational numbers. You know, the numbers, the decimals that never end and they don't have patterns or anything like that? Like, for instance, pi. That's an irrational number. Okay, it's an irrational number. So right now, my denominator is irrational, so I am going to rationalize it. I'm going to make it a number. And the way I'm going to do that is I'm just going to multiply it by 1. Okay? Now, hopefully in your brain, you're like, wait a minute. If I multiply it by 1, nothing's going to change. Because isn't that true? If I told you, hey, you know what, I feel good, everybody take your grade, and I want you to multiply by 1. Right? If I multiply by, what's going to happen? Nothing. Nothing's going to change. So does everybody agree by me multiplying by 1, I'm not going to change this number? Okay, now notice though, I wrote by a unique one, because it's not just going to be 1, it's going to be something that I make up, that it's still going to be 1. So for instance, it's actually a very simple one. What I'm going to do is I'm going to multiply this by the square root of 3 over the square root of 3. Does everybody agree that that is 1? Okay? Even though it looks a little bit more complex, that is 1. Correct? So now, why would I do that? Well, on the last one, first of all, how do you multiply fractions? Just straight across. So square root of 7 times the square root of 3 is square root of 21 over square root of 3 times the square root of 3 is square root of 9. But wait a minute, there's still a radical. But guys, the square root of 9 is really just what? 3. So guess what is no longer in my denominator? A radical. That's it. So now I have Karina. Karina, she's like, is that it? Yes and no. Okay. At this point, what you should do is say, can I break my top part down even more? And that's just like what we've just been doing, right? But 21, can I break 21 down? Seven and 3, but the problem is neither one of them is perfect square. So is there a point to that? No. So I'm just going to leave it as the square root of 21 over 3. Yeah, so let's just say it was, I don't know, 24, like we just did. So that one reduced to what? 2 square root 6? So then you would have to reduce it to 2 square root 6 over 3. What happens a lot of times, Karina, is that maybe the number that you pull out can be canceled on the bottom or even reduced. You know what I'm saying? So always when you get to this point, guys, see if this number, the top number, can be broken down even more. If it can, then do it. If it can't, then you're good. Any questions? So is it always going to be square root of 3 over square root of 3? No. It's going to be what? It's going to be whatever's here. Does everybody see that? So that's why it's called a unique one, because it's unique to every problem. Okay? It's unique to every problem. Any questions about that? Did y'all remember doing that? Okay. Well, this is called rationalizing the denominator. Basically, the clue is this. I never want to see a radical in your denominator. So if you're ever doing a problem and you give me a radical in the denominator, I already know you're wrong. Okay? Because you did not rationalize it. All right. Very simple. What about using square roots to solve? Using square roots to solve. Okay? So this is basically just algebra 1. Okay? This is basically just algebra 1. If I told you 2x squared minus 16 is equal to 34, and I wanted you to solve. So, of course, in the end, what do I want? X equals something, right? I want x alone. Okay? Could I factor this? Not really, because there's no what? Well, there's a C, there's no B. So, I mean, could you factor it? Probably, but there's no point in doing it. Because this is actually simpler than it looks. If I want you to solve, I want you to get x by itself. So that means you need to do what? Get rid of stuff, right? You need to undo what's being done. So in this case, Alexis told me to add 16. Is that right? If I add 16, I would be left with 2x squared is equal to 50. You with me on that? And then now what? Divide by 2. Divide by 2. Okay? Okay, so time out. How do I know what order to do it again? Did we talk about this? SADMEP. SADMEP. Does that look familiar? It's what? It's PEMDAS backwards. So do y'all know what PEMDAS is? Like what it actually is? What is it? No. Not what it stands for. What is it? Say that again. Order of operations. It's the order in which you do things, right? PEMDAS is your order of operations. It's the order in which you do things. SADMEP is your order of solving. It's the order in which you undo things. Does that make sense? So wouldn't it make sense that it's backwards? So when you're solving, think SADMEP. This tells you the order to get rid of stuff. This tells you in what order to get rid of something, okay? So what should I get rid of first? Any addition or subtraction. Because remember, these are basically the same thing, right? So first you get rid of any addition or subtraction. Isn't that what we did? We got rid of the minus 16, so we added it. And then you get rid of any multiplication or division. So this is where, do you understand why I'm not going to deal with the exponent? Because I still have some multiplication division. Got it? So now divide by 2. That would give me x squared equals 2. And then now look, the only thing I have to deal with is an exponent now. And how do you get rid of that exponent? In this case, you're going to square root. So x equals 2. Thought we talked about this. There you go. Don't forget. Don't forget. Any, and this is, I'm writing it in capital letters because I'm screaming. Anytime you square root anytime you square root, did I? Well, see, I'm so angry that I can't spell. There are two answers. Anytime you square root, there are always two answers, except why only except in Pythagorean theorem? Because you can't have negative distance. So it's not that there's not an answer. It's not that there's not a negative. I just tend to ignore it, right? But anytime you square root, there are always two answers, a positive and a negative. Actually, I should change that to not just square root. Do you remember what I said? It's anytime you even root. It's anytime you even root. Now, we rarely take a fourth. I never ask you what's the fourth root or sixth root or eighth root. But is it possible? Yes, it is. Okay, so it's actually anytime you even root, you always get two answers. We good? All right, we're flying. Couple more. Ooh, your favorite. Your favorite. Quadratic formula. Quadratic formula. Does anybody know it by heart? Yes, you do. Come on. The quadratic formula is A. So, this is your quadratic formula. This is a way to solve the quadratics. Now, if you're solving, you're looking for the solutions, which means you're looking for the x-intercept. So this tells you where this graph crosses the x-axis. Now, why would I have to do this? Why would I have to use the quadratic formula? Because I showed you how to just factor it, right? Can't you just factor and separate and solve? So then why do you need the quadratic formula? Sometimes you can't factor. Simple as that. Sometimes you cannot factor. Okay? So sometimes you cannot factor. Okay? And quadratic formula works all the time. It always works. So even when you can factor, you can use the quadratic formula. Okay? It's a little bit longer, and some students find it, tedious. There's the word. Find it tedious, but it works all the time. Okay? So let's see if you know how to use it. By the way, what the heck are all these A's, B's, and C's? It's from the standard. So good. So Canoe said it's from the standard form. So in order for me to use this, my equation has to be in standard form. So don't forget, standard form means that it's equal to 0. So if there was an equals to 2 or something over here, it's not in standard form, but can I make it? Yeah, just get everything at least to one side. So is everybody good? My A is what? My B is what? My C is? So let me write that one more time. A is 1, B is -5, and C is -14. So guys, this is actually really easy. You're just going to plug it in and hammer it out. Okay? So, x equals. Why is it 5, Olga? So she said, look, it's supposed to be a -b, but my b is what? So a negative of a negative turns it into a? So it's 5 plus or minus the square root of, and then how do I write that? Good, because it's a negative, it's going to be a -5 squared minus 4 times 1 times -14. All of that over 2 times 1. Now, I know you don't have to write 2 times 1 because we already know the answer, but I write it because you got to get used to just plugging everything in, right? So now, here's the thing, guys. Here's the thing. Here's the way I tell my students to deal with this. I want you to deal with the radicand. So right now, deal with the stuff that's underneath the radical. Just the stuff that's underneath the radical. So in your calculator, you can put it exactly the way we wrote it, but do not square root, okay? Do not square root at this point, okay? So in the calculator, put what's negative 5 squared minus 4 times 1 times negative 14. What do you got? 81? So you get the square root of 81 over 2. So if you get this, you're going to get the square root of 81. Now the reason, guys, so um, is this lucky for us, this right here? Because what is the square root of 81? 9. So the reason I tell you not to square root yet is it always going to be a perfect square? No, so what do you think you do when it's not a perfect square? Try and reduce it, and then basically you're done, right? So in this case, though, it is a perfect square. So I get 5 plus or minus 9 over 2. Now, this is a lot of students get confused here. What's going on here? There's actually two parts. There's a 5 plus 9 over 2 and a 5 minus 9 over 2. Okay? So I actually am going to get two answers. What is 5 plus 9? 14 divided by 2? Positive 7. And what's 5 minus 9? Negative 4 over 2? Negative 2, right? So I actually get two answers. X equals to 7 and x equals to negative 2. Again, but my warning is, that's why I have you deal with the radicand first, right? Because is it always going to be a perfect square like 81? No. So if it's not, all you're going to do is reduce this if you can. Let's say it reduces to 3 square root 5 or whatever, right? And you literally just stop right there. There's no point in splitting it up because I don't want decimals anyway, right? So your answer would be 5 plus 3 square root 5 over whatever. Does that make sense? We good? All right, let's finish it off. All I want you to do is try this one on your own using the quadratic formula. Use the quadratic formula on this one. Okay, tell me what to write. So what's my A? B? C? Negative 20. All right, so then x equals what? All that over. Okay, simplify the radicand for me. So negative 3 plus or minus the square root of 169 over 4. Does this simplify? What's the square root of 169? Lucky, lucky, it's 13. So negative 3 plus or minus 13 over 4. Split it up. Negative 3 plus 13 over 4. Negative 3 minus 13 over 4. What's negative 3 plus 13? 10 over 4. So 5 over 2, very acceptable answer. So 5 over 2 is okay. You could give me a fraction, which would be what, 2.5? So that's right. Yeah, 2.5. So that's okay too. A decimal, as long as the decimal is clean. You understand what I mean by clean? Like 0.5, 0.25. I don't want 0.5376, 10, blah, 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 because that's not right anyway, right? So if it's 0.5, 0.75, I'm okay with that. Okay? Negative 3 minus 13 over 4. Very good. So you get two answers. X equals 5 halves. X equals negative 4. Any questions on quadratic formula? Too easy, drill sergeant, right? All right. Last thing, max or min. You've heard it, you know it. Okay? It's actually not that difficult. I like to break it down in steps in case you haven't noticed. It's very simple. Okay? Step number 1 is determine if we have a max or min. Now, I know you're thinking, well, yeah, that's the point. That's the point of the question. No, no, no. I don't mean what is the max or min. I mean, do we have a max or a min? Like, what is it going to be? Is it going to be a maximum or a minimum? How can you tell? Without doing any math, how can you tell? Good. Because remember, these are all parabolas, agreed? These are all parabolas. And so basically, you only have two types of parabolas. You have a positive parabola, right? So this is a positive parabola. And you have a negative parabola. Now, I know that, yeah, they're all moved around, all that good stuff, but it's pretty simple, right? It's either going to be a positive parabola or a negative parabola. Agreed? Now, if it's positive, that means that I have a bottom point, which means that this is a minimum. And if it's negative, that means I have a top point, which means it is a maximum. So that's what I mean by determine. So does everybody see already what are we going to have in our equation here? What is it? Is it positive or negative? So looking at your x squared, the a determines that. The a determines whether it's going to be opening upward or downward. So in our case, our a is negative, so I know it's going to be opening down. So this is going to be a max. So I already know that it's going to be a max. So max equals what? All right? Step 2. Okay? Step 2. I need to find the x of the vertex. Because remember, aren't these points my vertex anyway? Right? I need to find the x of my vertex. How do I do that? It's actually a pretty simple formula. Negative b over 2a. So your x is always going to be your negative b over 2a. Okay? So, x is negative b over 2a. In our case, it would be a negative what? 12 over 2 times negative 3. Okay, now do the math. Negative 12 over negative 6, which is 2. So does everybody agree that x is equal to 2? Right? So my x of the vertex is equal to 2. Step 3, find y. How do you think I should find y? Plug in x. We know x, so plug in. So you're going to find y by plugging in x. You're going to find y by plugging in x. All right, well, that, bless you. Okay, so remember, this is a formula, isn't it? An equation is just a formula. So I know x, so how do I find y? Simply by plugging it in. So y is equal to negative 3 parentheses 2 squared plus 12 times 2 plus 11. Now I'm not asking you to do this in your head. You have calculators. Okay? So in your calculator, tell me what is all this. Is that 4, negative 12, 24 is 12, plus 11. Oh, I got it, 23. Is that, what do you get? 23? So y equals to 23. What did I just find? I have an x and I have a y. I just found my vertex. So my vertex is 2, comma 23. Does everybody agree with that? The vertex is 2, comma 23. Now remember, I was trying to find max or min. The max or min is always the y value of the vertex. the max or min is always the y value of the vertex. So what is my maximum? 23. What does that mean? That means that the highest it'll ever go is 23. So every y value is going to be 23 or lower. I know that. Okay, so very simple steps, guys. First, determine whether it's a max or a min. You got to know what to call it, right? You got to know, oh, it's going to be a max, it's going to be a min. Then you're going to find your x by using this simple formula. Find your y by plugging your x in. And remember, so you just found the vertex, right? You just found it. Actually, you found more than that. So you found your max because it's the y value. Does anybody know what this x value represents? Say that again. It's actually my axis of symmetry. Because you remember that line that goes through, my, uh-oh, did I lose power? I did. That line that goes through my symmetry, isn't it? It goes through my x coordinate. It's my axis of symmetry. So the x is actually your axis of symmetry. So the vertex tells me a lot of things. This is my axis of symmetry. This is my max or min. Okay? Any questions, guys? Any questions? Fantastic.